Now I would call upon Dr. S.P. Sangeeta Ma'am, Vice Principal Academics, to welcome the gathering.
Thank you, Subhapriya Madam. Respected Chief Guest for today's session, Dr. Chockalingam Aravind, Vaithilingam, Program Director, Electrical and Electronics Engineering, Faculty of Innovation and Technology, Taylor's University, Malaysia. Respected Director Research, beloved Principal, Vice Principals, Dr. L.K. Hema, members of AVIT Center for Continuing Education, faculty colleagues, and external participants from other institutions, a very good afternoon to everyone. ACCE is proud to host this international webinar on constructing research with intent. I'm really proud and glad at this moment to share with you all that within a very short span of time, from the day of inception of this ACCE itself, we could organize several webinars aiming at upgrading all our faculty on NEP concepts, mentoring techniques, teaching learning process, and now on research. On behalf of AVIT Center for Continuing Education, I cordially welcome Dr. Chockalingam Aravind Vaithilingam, who has rich experience in research and innovation in sustainable energy and an expert in the adoption of design thinking. Welcome, sir. I extend a warm welcome to our Director of Research, who is the driving force, who always insists that it is essential that all teaching faculty should engage actively in research so that all educators gets familiar with research-based teaching technologies, which will definitely help the students to come out with a lot of innovations in their career. Welcome, sir. I extend a cordial welcome and also thank our beloved principal for his constant support, arranging all the webinars, and especially this webinar is arranged with his student, Dr. Aravind, and his continuous guidance in organizing various fruitful events under ACCE for upgrading our faculty on all emerging areas. Welcome, sir. I welcome all our faculty colleagues and participants from other education institutions. Thank you.
Thank you, ma'am, for your warm welcome. Now it's my pleasure to call upon Dr. G. Selvakumar, Sir, Principal AVIT, to felicitate our chief guest with virtual memento.
As a token of love and appreciation, a small memento from my side. I kindly accept Dr. Aravind.
Yeah, thank you very much, sir. Thank you very much.
Thank you, sir. Now I request our principal, sir, to deliver the presidential address.
Very good afternoon to you all. Beloved Dr. Aravind, Program Director of Taylor's University, Malaysia. Beloved Director Research, Vice Principal Academics, Vice Principal Admin, Vice Principal Part-Time Studies, Coordinators for the AVIT Center for Continuing Education, and dear faculty members of AVIT and other external institutions. Once again, a very warm afternoon wishes to you all. For a teacher, the proud moment is to see that his or her student grow up and occupy the top positions, be it in the academics or industry or even general public, general society. And I'm very happy that I have seen as a small kid in 1995. In fact, I was also just 26-year-old that time when I just started my career in Institute of Road and Transport Technology, and he was my first batch student of RwI. And for the past 26 years, I'm seeing his growth. It is really exponential. And after serving in India, he landed up in Malaysia, and he is currently working in one of the topmost universities in the world. I can say it is in the top 500 QS world ranking university, Taylor's University, and which is first top private university in Malaysia. So he's occupying the topmost position, and not just that he's working as a faculty member, he's also program director of electrical engineering. So it is really a proud moment for me to invite my student to this program, and probably this is the third or fourth occasion I'm disturbing him. So wherever I work, I try to utilize his services, and he is a academician and active researcher. He has published many quality papers in quality journals, and he has got more patents, and he has develop more product also. Apart from teaching, he is very passionate in research, and that's the reason why I'm continuously disturbing him. And thank you, Aravind, for obliging my invitation and joining today. Probably this 1.5 hour session will really enrich. It will give more information to our faculty members to do active research, and probably the day may change from today onwards that faculty members will be knowing about the actual research, how to carry out the funded research projects and other aspects of the research. I'm really happy to welcome you once again for this program, and I request all the participants to be more focused in the research activities, because normally we spend most of the time in teaching, and being a teacher of a university institution, we need to focus more on research. I know that AVIT faculty are doing better compared to other institutions in Vinayaka missions, but still we need to reach greater heights, and we need to scale different heights in the days to come. With this, once again, I wish this program all the success. As rightly pointed out by VP Academics, that AVIT Center for Continuing Education is organizing many programs. It was actually inaugurated only 6 months before, and within the 6 months, we could be able to organize many programs, and there are many more programs in the pipeline. Everything is towards the benefit and betterment of the teaching community. So I wish the ACCE all the best, and the participant a wonderful, fruitful session for the next 1.5 hours. And I thank everyone for joining today's session. Thank you.
Thank you, sir. Now I request Dr. S.A.V. Satyamurthy, sir, Director Research, Vinayaka Missions Research Foundation, to deliver special address.
Thank you, Dr. Suvapriya.
Thank you, sir.
Respected Dr. Chockalingam, Aravind, Vaithilingam, Dr. Selvakumar, Principal AVIT, Dr. Sangeeta, Vice Principal Academics, Vice Principals, HODs, faculty members, and some students are there, students. Very good afternoon to all of you. I'm really happy to participate in this webinar after a long time being conducted by AVIT, the AVIT Center for Continuing Education. Let me be a little frank in the beginning. Though I have more than 40 years of experience in research, I didn't understand the topic in the beginning when I read it for the first time. I read it multiple times. I thought that Dr. Sangeeta is conducting and construction word is there, and I thought it is something to do with civil engineering. Then when I contacted the organizers, they told it's nothing to do with civil engineering, it is something to do with research. And then I read the thing once again, and then I presume I understood it. Let us see in the last coming few minutes whether I understood or not. Just one second. Doing research with a specific goal in mind is always good, and it's always desirable. And in atomic energy department, where I spent most of my career, we used to call it directed research. As you know, research is very human intensive, intellectual intensive, and requires large amount of commitment. And many times it's time consuming and requires large amount of funding. When that is the case, obviously, you should start your research when you want to do research in a specific domain. You should define your problem very well in the beginning itself, and you should know what is your target in mind, and you should have your research methodology work towards that particular thing. One good or bad thing about engineers is we always, mind you, I'm also an engineer. We always want to do our research, that our research shall lead to a development of a product which we should be able to commercialize, which we should be able to get some money out of it. We always look for return on investment. I was also having a similar ideas in the earlier part of my career. But when I became senior in the atomic energy department, I started realizing that engineers really do not do the research in real research in quotes what physicists or chemists or biologists will do. What we do normally is a translational research or a concept that is proved by a physicist or chemist. we convert into a product or a process or a theory that can be monetized. Yes, certainly. I mean, our final goal is monetization. Whether it couldn't be in terms of money or it could be in terms of improving the comfort of life of the human being. But if you look at basics, most of the research is done by the basic sciences, physics and chemistry people. Just to give a few examples, today cell phone has become part of our body, and whether you use 2G or 4G or 5G cell phone, well, you are able to use it extensively, and now we are not able to live without it. And certainly this is the invention of an engineer, there's no doubt about it. But the thing behind is a physicist has found electromagnetic radiation can carry information. That is the basic research point on which the engineer has done the particular research. So for example, if we are using internet left and right, and for that fiber optic cables are spread across the globe. And again, the fiber optic cable laying or commissioning or providing the internet services, engineer may be doing it, but originally the basic scientist has found that how do we modulate light, how do I send the information through the light. This is done by the physics people. And same, I go back to Madame Curie, who is the only woman who got 2 Nobel Prizes. She did invent radioactivity without really knowing where she is going. Same is true with Albert Einstein, who invented theory of relativity. So the basic point which I intend to make is most of the job which we engineers do is based on the foundation which the basic scientists will do. I mean, all the examples which I have mentioned belong to that particular thing. But well, with time, we also say that we are also doing research. Research, by definition, if you look at identifying, I mean, making a good product or making a good process or making the life comfortable, that way we are doing it. In that sense, yes, we are also doing research. And I always believe and I always say that our research has to be goal oriented. We should always have what we intend to do, and always we should have a time frame in mind. We should always have how much money is required. All these things thought about in the beginning itself. We cannot be in an open-ended research. But again, without taking too much of time, I mean, open-ended research is not that bad in the sense that, I mean, I want to propagate it. But today we are where we are because of the open-ended research that is done by our ancestral scientists, the Madame Curie or Einstein or many of the people. I can drop a number of names. But their thing is a more, I mean, open-ended research. They stumbled upon certain findings that became inventions. Finally, the engineer has converted them into products. So I would say that yes, the topic is highly relevant, especially for engineers, where we should define a particular problem with an end intent in mind, with the specific time frames in mind, the budget in mind, and we should targets in mind, and we should proceed towards that. And I'm happy that AVET, though a long way to go, is doing much better than some of the institutes in VMRF. Of course, ours is more of a health-centric university, so comparing engineering college with a medical college may not be 100% fair. But yes, we are doing a good job, but there is a long way to go. And I always say that keep telling all our colleagues. So to close my remarks, I would once again emphasize the topic is highly relevant, and the AVET Center for Continuing Education has taken a topic and invited a very good speaker, what I hear from Dr. Selvakumar. Thank you very much for giving me this opportunity, and thank you. I hope with this AVT will prosper much better in research. Thank you.
Thank you, sir. It's honor and privilege for me to introduce the chief guest for the day, Dr. Chockalingam Aravind Vaithilingam, Program Director, Taylor's University, Malaysia. Dr. Aravind is heading the Electrical and Electronic Engineering Program of Faculty of Innovation and Technology at the Taylor's University, Malaysia. He has wide experience in research innovation and enterprise in sustainable energy and mobility. He is a professional chartered engineer registered with the Engineering Council, United Kingdom. He holds doctoral degree in electrical power engineering with his PhD work earning gold at MTE 2013. He is a very frequent speaker at various international and national platforms. Dr. Aravind is also a professional technologist with the Malaysian Board of Technologists, a member with the Society of Engineering Education, Malaysia, senior member with IEEE, and a member of IET, United Kingdom. He also heads Verticals, a high impact research cluster with the university. He has published over 150 index documents in sustainable energy and mobility. His works are recognized in local and international events, congress, and exhibition with 15 over awards this year alone. Dr. Aravind has acquired grant value of USD 3,36,365, of which 46% as principal investigator since 2007 and industrial consulting projects with Daikin, Malaysia. He holds multiple patents in energy applications, with the more recent on hybrid low-cost solar energy harvester in 2021. He is also a developer of multiple award-winning code enterprise framework he used to develop teaching, learning, research, and consulting solutions. Currently, his projects include spearheading organization-wide flagship project on energy infrastructure totaling to USD of 88,000. Thank you, sir. We are very much glad to hear your session, and the session is yours.
Thank you very much, Dr. Selvakumar, Dr. Sangeeta, and also to Professor Prinarana. I think he summarized what I intend to present today. So I hope that the next 1 hour plus, I will not make you keep bored, right? Definitely, you will carry forward some key points or key takeaways which might help you in a progressive, what we call as a progressive research mindset. Right, mindset is very important, first of all, right? And I hope that I will live to the expectation of my teacher. I always cherish Dr. Selvakumar to be guiding us when we were simple undergraduate students at IRTT. He wrote that. Okay, let's go into the topic. I will reserve the cohort engagement. So I want to do some busy type, but because of the time frame, right, we will keep that one for the end of the session, right? If there is an opportunity, then we'll play the game. If not, then in some other occasions, we will try to cater for it. Okay, so I asked through Dr. Sangeeta, some of your colleagues to do a survey, a simple survey for us to understand where we are at this point of time, and what we intend to do, and are we on track with what we visualize ourselves in the future, right? So this is the statistics output of your survey, right? As you can see from the last component, just give me a minute, I will. Okay, sorry. So if we look at the last aspect of, so whether we feel our research is required by the society or not, that means whatever we do in the lab or in our research, whether it can be straight away applied to the society or not, right? So I think more than 50% of us responded as yes. That means we find there is a larger gap between what we do in the lab and what is required by the market. In contradiction to what you see as a, how do you like to see your research mature, right? So in that case, I think most of us responded as be part of the solution that can create value for the nature, a value for the health, and also value for the society at large there, right? And of course, the fundamental question is why you need to do research. It's very surprising to see that most of you not opted for peer pressure, which if I do the same survey in Malaysia, it's a different story. The peer pressure comes at the topmost priority than other components here. But where I want you guys to have a look into that one is, we feel that our research at what we are doing is not straight away or indirectly or directly implicating to the purpose, right? Towards what is needed by the society. Society here means, I mean, as it responds to the, you can take as an SDG goal. All the SDG goals are related with the societal issues there, right? But what we find or what we do as see our research in terms of the maturing is we want to be part of this solution, right? But we are not part of the solution there, right? So this is primarily is because our research is not done with intent, right? That's why I draft this title, which is called Constructing Research with Intent. So which we can call in a different names, like open-ended is one way of calling it, direct related or direct research is another aspect, or you can also call as a purpose-driven research, right? So what actually happens between the past research and the so-called present research, say for example 30-40 years, is we are getting away from the purpose-driven research towards cost-driven research. That's the biggest challenge what we are facing currently. As a matter of fact, about 87% of the research we do in the lab, it doesn't even get out of the lab. Of course, it ends up as our publications or maybe patents or whatever maybe, but it is not transferable into a business value. Business value here means what I mean is, like, it's not necessary it has to convert into a money or something which is actually generating revenue, but at least it can solve some of the societal problems. That's what we call as a business value here. So in this session, I will try to explain how to construct this research with intent as you start to building up a simple problem or simple challenge right from your lab, and how you can bring that one to the market, or the other way, what the market is needed and how to construct your research based on your market demand. I'm representing Taylor's University, as mentioned by Dr. Selvakumar. So we are #1 private universities, Malaysia and Southeast Asia, and we are ranked 332 among all the universities around the globe. So our pedagogy at the School of Computer Science and Engineering is project-based learning. That means we believe the students can learn by doing projects. By doing projects, then they can make a number of mistakes. Then they can learn from the mistakes. Then they can mature to become a better solution provider even before they graduate. That's what our pedagogy is about. I'm currently heading this vertical research cluster, which is a product of the Code. Code is our research teaching learning enterprise framework, where we use this one as a base to design our teaching learning, our curriculum, even the strategies of commercializing the teaching learning. Also, the same goes with our research and enterprise. All our projects which we do from the lab are aligned with this within this code framework. In a simple way, code framework is nothing but it is intended to create a value for whatever the challenges that is posed to us, whether it is coming from a teaching learning or from the research perspective over that. Code stands for conceptuate. Contemplating the idea, then organizing the tools and the techniques that is needed, then deploying the tools and techniques in the way you want to visualize, and finally evolving the product into the next level. That means to the next level of commercialization. That stands for this code framework there. So as mentioned earlier, also we have won multiple awards for this code framework for teaching learning, for our training purposes, and also for some of the product we developed from the lab there. As mentioned earlier, I will show how to construct the research with intent, then how to create an impact from the by doing this research with intent, and finally 2 of the case studies of what we have done in Malaysia. So this is more familiar for most of us. To always we talk about there is a larger gap between the academic and also the industry, right? Academic, we always tend to have a research as a means to get our work published. Probably that publishing work can increase your H index among the your peers. Your impact factor, your personal impact factor might rise. So that can put you in your career advancement within your universities, or you can go for the next job, a higher jump for the job. Right. So this is what we look from the academic point of view. And lately this becomes a priority in the last 30-40 years of time period there, right? Where we have a number of colleges and universities are coming up, where everybody become very addicted to the number of likes we have on the Facebook, right? So that's the generation we are now, where we want to have a fast and rapid way of getting the number of papers published, increasing the impact, thereby increasing so-called impact, thereby we can create ourselves a name within the scientific society there. But is it, if you ask yourself, like, is it the purpose of you to have a strategy on that way, right? So if we start to have a strategy in that way, every year at the start of January 1, you have to reset the button, meaning that you have to start fresh from zero publication. Then you have to build for the rest of the 10 months or 12 months of time period to publish maybe 6 paper, 10 paper, 12 paper. Then at the end of the December, once again, you have to start back. You have to reset your button. Once again, that you restart the whole process to be there, right? But that is what is actually the educational domain or the professional society is now facing up. Primarily is because coming from the peer pressure. Like my friends published 2 papers in a high impact journal. It actually put more pressure on me to publish in a high impact journal. So, but without doing a appropriate research, right, results, it's impossible, near to impossible for you to get published in some of the aspect from here. But when you look from the industry point of view, industry, they don't care how many papers you publish, right? Industry, they just look at whether the outcome of your scientific knowledge, whether this can transform people's life easier, or whether it can transform the process to become simpler or optimized, whether it can make the people to have a better health, better environment, carbon-less environment. Those are the things is what industries are looking forward at. They are not worried about whether you publish in Q1, impact factor 15 or 14, whatever maybe. So this is the larger gap that makes us to have a thought process to be in place to say that where we are stand and where our fundamental purpose of being a research needs to be there, right? The fundamental purpose of scientific research is to yield a commercialized product, process, or a service, right? That can make the humanity to become better prospect. But what we end up is somewhere here. So we publish, we document it, then we move on. We publish, we document it, then we move on. As a matter of fact, I know that one of my very good friend of mine, he's a senior professor. He's having H index of 100 something, a citation of close to 45,000. Right, but if you look at how many of the product or the PhDs he graduated has been able to, the PhD thesis that had to be commercialized is nil to 0. That means he's not even able to translate the 54 PhD graduates he has made. That means 54 PhD scientific theses into a commercialized model, not even one of the theses. So, but he's considered as a senior professor. He's considered as a very high scientific person. Yeah, sorry. So, but what we need to also think about is okay, so what I was saying, okay, so a senior professor, right? So he has a lot of journal, he has a high index. When people come to ask you about how many of this is actually making the scientific domain convert into a commercialized world, then it's nil, right? So as a matter of fact, you can argue with me to say that, okay, the fundamental purpose of a teacher or researcher is to make the edge of knowledge to go to the next level, right? We are not worried about whether this edge of knowledge can be converted to commercial world or not, right? But the problem is, if you create a lot of edge of knowledges, that means a scientific knowledge edge, you build up a little bit, right? Then you leave it for the next person to keep researching, right? So that means we are somewhere between the basic and the applied research, right? So we learn from our earlier PhD's thesis, right? The research gap. Then we try to come up with some solution, build a hypothesis, then do the research, funded, non-funded, whatever maybe, then build some sort of a knowledge, and then we leave it there. Then what happens is that the research keeps on bulging between the basic and applied research there. So it keeps on within the university or within the college or within your own students, right? If you are a senior professor supervising a number of students there, you're beating around the same bush with a little bit of advancement of the knowledge. But we don't know whether this knowledge is what needed by the industry or not, right? Without knowing what the industry needed, there's no point for us to keep researching further there. So that means we need to go to the next level of whether this knowledge can be really converted into some sort of optimized process, product process service, basically, right? Your research technically will lead to a product, product or an upgraded product, a process, an optimized process, or a service, a better service. These are the only three things in which your research will end up with. Whether this knowledge we built in can be converted or adapted, can be adopted by the society or not, by the industry or not, right? So if it is not adaptable, that means the research what you are doing is obsolete. There is no point for you to do a research on that area there, right? This is how we have to first of all construct to see ourselves what we are doing as a research, whether it is aligned to what the society or the industry needed. If there is no alignment, then it's time for you to reconstruct your research strategy there. That means you have to change your intention towards or you have to change your strategy towards executing your research into a different perspective there. So generally, university and research innovation centers are usually applied between these two parties there, right? Innovation is technically lead to a pattern, but getting a pattern is not a great thing, right? Making this pattern to become a revenue conversion, or it can be adopted by the society, is what the important aspect there, right? So because sometimes, when you see that people are getting pattern, it doesn't mean that it is actually as a very good innovation. Innovation needs to have a transferable component that can generate value addition. Value addition here means it can be from in the way of money, or it can be in the way of adoption by the industry, or adoption by the company, or adoption by a startup, some sort of aspect from that. Okay, and this adaptability will drive these, give a new direction to see to that industry to say that, okay, I can adapt this one, but still I have some gaps that needs to be addressed, right? That gaps will become a new direction, and this will create a new knowledge society to make your research gap to be coming from the industry and not from your senior's PhD thesis, or from your friend's PhD thesis, or even from the publication thesis. So the biggest mistakes people do is, like, when they start the PhD, they will go and look at to study the literature review in their area. It's fine. You have to do that aspect there to start with. But you also need to see that what the commercial world development is there. Because as a matter of fact, whatever we publish in our journals, for example, it will take about 5 to 7 years to reach the commercial world there, right? 5 to 7 years time is very, very huge, huge gap there. So that's why always it's important you do the literature review. At the same time, you also need to look at to start with talk with the people from the relevant industry, and to see that whatever the PhD you are doing, whatever the research you are trying to do, it has a value in the near future or not. Once we start to build that way, then this becomes like a circular aspect there. Then it becomes the dynamics of your research group, if you have a research group, or if you are a supervisor who wants to have an adoption of the circular component, then it makes it to meaningful research. Thereby your construction of your research is with a purpose or with an intention to provide a solution for the industry or for the society at large there. So that's why you call us the important component is, don't think about basic research and applied research. This one anybody can do. The important thing is like how this research can be converted with value, and whether this value can be a part of this future knowledge society or not. Right? If you're able to address these two, even at the start of your PhD or your research project, then the success rate of your or the conversion rate of your research into a product is very highly unlikely there. So let us try to construct this one with a higher order framework. I call this as a higher order framework because we need to have some sort of framework in mind if you want to drive your research in, for example, 5 to 6 years of time. Okay, you cannot start your research today and end up this year, right? You have to slowly construct your research, expertise or your domain or your research center or a center of excellence, over a period of time, right? So we classify this one as a level, stages, stakeholders, outcomes, and the well generation based on what you are seeing in this case. So we classify this one into 3 phases. The first stage is identifying building up what you do in your PhD, in your realistic PhD component there, right? So you try to identify a problem, a research problem, then you get an idea, then make the idea to become like a concept, convert into a concept, and convert this concept into a workable model we call as a proof of concept. Generally, this happens with your postgraduate students, maybe master's or PhD level, and primarily this one will be yielding you a degree, a human capital. That means you develop people with a high qualification, a professional qualification there. Okay. The second stage or the phase 2 of your higher order framework will be on how to make this whatever we have made as a proof of concept, whether this one can be brought to the market or not. Right? So that's where we do the validation and the demonstration to the real environment. That means you bring the proof of concept, upscale it, then you try to demonstrate that it has a feasibility to be adopted in a larger scale there. So this is where the validation, the demo will occur. Generally, this is done at the level of center of excellence, where center of excellence will look into whether the direction of this university or your strategic vision of the universities lies within the scope the proof of concept is giving up, right? From there, you will put up some resources over there to do here, to do the validation and the demonstration in the real-time environment. Then, of course, after you do demo it, then you have to go bring this one to the governmental body if there is a governmental involved. If there is a medical involved, probably you need to bring to the medical board, you need to get some ethical clearance, all those things before you can start to commercialize that. So is where somewhere between L4 to L7 is where your startups, your unicorns are slowly trying to build up over a period of time. Okay, so why I'm showing this one to a bunch of renowned people or knowledge people here is like, if we don't understand this framework very well, right, then it's very difficult for us to translate this one for a student who is coming in year 3 or year 4, where he has an excellent idea and he want to convert into a part of a startup or a unicorn maybe in year 4 or year 5, right? If we are not very clear, or if you are not in this whole process, if we have not gone through this whole process, then it's very difficult for us to guide our students or the future, what we call as like entrepreneur or technopreneur at large there. So it is important for us to look from the research component, that is research group, you have to move to the stretched research component. I call this name as a hard desking space. Hard desking space is something that comes out during this new normal period there, where in the future you will not see a physical place even for the principal or the CEO or whatever maybe. It will be an open space where people, if they want to come to the campus to do the job, they have to pre-book, they have to use that space for that particular a period of time, just like moving from one place to another place over there is what we call as a hard desking spaces there. So why I use this term here is when we do a research, we should not be put ourselves within this research component we are trying to do. Say, for example, if you're doing a project on a solar energy system there, you develop a solar energy solution there, right? So you should not be stopping there as a solar energy research component. Then you have to stress this one to the application and where this solar concept which I have developed can be applied in the in a process industry, for example, or for example in a standalone unit in a place like Ooty or Kodaikanal, whatever. This is called as stressed research there. When you start to stress the research there, it will try to show you an avenue of money coming in slowly. So it will be making people to have an interest on your research, to say that hey, I have a solution for this one, and this one can be applied to your pasteurization industry. For example, your milk industry. Milk industry needs a temperature of about 80 to 90 degrees centigrade easily, or 100 degrees centigrade easily. If you have a concentrated solar photovoltaic system, that means that is nothing but a simple trough that can generate very much of heat there. Okay, I have this idea, then I bring this idea into an application mode. Then I bring this one to the milk industry and say that, okay, you can make this milk industry to become an energy efficient industry by adopting this solar technology. Instead of you using the heating, the thermal heating is usually using a gas or electrical system there. You can use this type of renewable type of system over there. This is what we call as a test research there. Why we don't go from the research to the test research is because we are very particular in not to make our research to fail, right? This is the biggest what is called like a negative thought process you should not be having as a research, right? When you start to do a research, you should be having in mind that any research will not yield 100% output there. There will be always a failure over there. So the important part is like what you learn from the failure. How do you analyze the root cause of the failure, and how do you overcome that one? We don't want to go from the research to research because when we fail, we feel that somebody from outside will mock us to say that, okay, this guy is a fear of experience and he is not able to, provide a simple solution like this, right? So this fear actually makes us to be within our what is called comfort zone, which we call as a research, where we want to churn out of what we are comfortable within our domain. But I would like to invite you guys to, if you are towards the maturing of the research, try to take one simple, what you call like solutions you have developed, and try to bring it to the closer to the application point of view. And you will slowly try to see that money will start to coming up for you, right? The more money you have the more autonomy to pump it back that money to do whatever the research you wanted to do. We call this as a return on zero, right? In our university, what we try to do is we try to pump in the money at the what we call as like a support funding when we start our career. Once we come up with a solution, it's our job to go and find a resource for our funding. Right, we stress the research, then we go to bring the industry on board. Then industry slowly start to fund the project there. And slowly, what happens is whatever the money I spend from the university, it will be the revenue back to the university. It's what we call as a return to zero. That means we try to make an investment early, then we try to recover it back so that the whole process will become a clear ecosystem at large there. So once you have this test research there, then probably you can think about the next level. Next level, it can be an entrepreneur, technopreneur, or intrapreneur. Intrapreneur is somebody who can bring innovation idea within the company you're working. For example, you are a staff, you can bring an innovation idea to your principal, right? And be part of this entrepreneur solution for the whole segment there, right? This is what we call as an entrepreneur component there, right? So all this can be done only if you have your mindset to get away from this L1 to L3 and move towards L4 and L5. So as I warn you also, L4 to L5 is a risky part. But if you take the risky, then you will slowly start to love this risky component. When you start to see it is actually reaping fruits for you. Right, but saying so that what are the biggest challenges or biggest conundrums that is actually making us not to move on, right? So the important part is like probably you are listening to me for 1 hour, you get more excited, you want to start fresh from tomorrow, right? But every day I cannot come and talk with you for 1 hour, right? So there should be sort of a mindset change within ourselves first of all before you start to think about strategizing your research component. So specific or very specific or specific questions people will ask like, by doing this one, will my work performance become better or not? Right? This is a question people will have in mind. Of course, when you start to know what are the terms of L1, L2, L3, like technopreneurship, entrepreneurship, startup, unicorns, then I think it makes us to become more younger. I mean, at least for myself, when I work with younger people, it makes me to become very younger. When you start to become younger, the ideas will be starting to pour a lot. right? And it makes you to become very confident. It makes you to become more performance oriented compared to your peer, right? Assuming if your peer is also having this this set of mindset there, right? So now this becomes a synergic or a healthy environment where everybody will start to think about performance in their life, and it actually helps the growth of the people at large, right? So we need to mentally break our this specific conundrum from us. Never think about whether this is going to convert into my work performance appreciate or not, right? This is basically to construct your own research future direction at large. There. The second thing, of course, we are as a teacher, we are the very what we call very slow to adapt new things, right? As we know that we still follow the same textbook of what we are following for several over years. Even I don't know, William Hart is still followed for electromagnetic fields even today, right? But there are institutions, there are universities where they want to challenge the status quo. You need to start to challenge the status quo, but of course with common sense, right? That can makes you to become come out of the grove, right? The moment you come out of the grove, as I'm telling, like you will be feeling a pinch of salt. That means you will be more pressurized than what you are doing. But without pressure, even carbon cannot become gold, right? So you need to have that type of pressure if you want to become better than what your things are, right? Someone like coming from 9 o'clock going to 4 o'clock, for them it looks like a shake things up there, right? But if you look at the statistics earlier we did, everybody wants to be the part of the change. Everybody wants to create a value, right? That means at the bottom of our heart and our mind, we want to contribute something which is really makes a sense for the place we are working up, for the people who we are committed to, right? Then the important part is like how do we talk with our peers, right? So it's very difficult when you want to motivate your peer who is not very much keen on to in your what is your thought process is there, right? So it's always important that everybody speak in the same language there. As a matter of fact, when I joined Taylor's University, we have this what we call as a I don't know whether I have shared with Dr. Selva or not. So we have what we call as like negative thoughts removal, right? So we don't use the word called problem. We call this a P word, because the moment when you see as a problem, right, you always have that negative perception, negative thought process there, right? So we completely remove this word problem and replace that one with a challenge, right? So when we say that, we don't say as a problem statement, we say as a challenge statement. The moment when you put the challenge statement there, it makes you to become positively approaching. When you hear the word challenge, they say like, okay, let's see what happens, right? When you see as a problem, you will always think about what will happen if I fail, right? That thought of negative thought process will makes you not to take that type of risk or challenges over there. Right, so that's why there should be a common unison among all of us to talk in the same language of as our peers, right? It is very important for us to have that type of communication within this research, within your research group. Like for example, when we give the orientation to my research group, I tell them very clearly what is my expectation and what is the language I want to see from my students over there, right? So clearly they know that, okay, this is what the expectation. Then once you have the common unison, then it's very easy for the things to keeps moving on with less ego. That makes it to become the things to become very more easier there, right? Of course, peer pressure is the most common across, but I'm very surprised to see the percentage of people from your side to give a very less marks for, or very less percentage for this peer pressure there. Okay, so how to design my research then, right? That means I know that I have to construct my research with certain purpose or for certain intent there, but how to create this value or how to create an impact with the construction of this type of research there. Okay, the topmost what you are seeing is what we are currently doing, right? We recognize the issue, we choose the best solution, test where you can and implement and end. That's all, right? So when you want to recognize the issue, we can go to literature review, we can study from the from other people work, then we try to make it as a gap, then we try to come up with the best solution. Best solution is the known tools and the known techniques. I know MATLAB, they know this optimization tool, you pick up, then you try to solve it. All these are known component there. That means you know everything, only thing you're trying to organize that one to put in a particular fashion here. As I tell you, this one will give you very high publication. It will give you very high index. But when you look at the zero conversion, the conversion will be zero, meaning that you do this one for this year, the next year you have to start from here. There is no cyclic structure over there. So probably a little bit of you create an edge of knowledge, you try to use this edge of knowledge, now become a research gap, then you try to do once again the same component from there, right? But when you look at the bottom component here, when you start to recognize the issue, you have to see from the point of commercialization component. Okay, mind carefully that when I say like business value, it doesn't mean like a commercial value alone. It means like that is creating a value for the user, end user, right? Value for the process you develop, value for the product you develop, value for the service you're going to give, right? So once you have that one in frame of mind, then you will be having a multiple number of solutions there. Say, for example, I want to create a solar, the same solar, whatever we have discussed earlier, but I want to create with a low cost solution there. Low cost means what? It can reach out to many number of people over there, right? Or I want to create something like a high impact, for example, a COVID-19 vaccination, right? That can make people to save their lives. Right? So that's what you have to see as the business value. The business value, not alone money, it can be an impact, or it can be some sort of convenience, or it's some sort of value addition to the existing system there. You can do this one only if you have this whole picture in mind. So meaning that you need to have value at the start, even before you start to construct your research problem. If you do that way, then it's easy for you to go through this research journey, and this research journey will be having a happy ending at last, right? And of course, this is completely unknown territory. The top one, if you see, it's a known territory. If you fail in some component, you always know that there is a backup solution you can refer to, and you can use that one to come up with a solution. The bottom one is an unknown territory where you don't know the solution, but it's a challenge that you would like to do, because it will create a new space for you, and it will create a return on investment, as mentioned earlier by Dr. Satyanarayana. Return on investment is very, very important. And I say this as a dynamics. Dynamics here means every day it will be a challenging aspect for us to do here. Okay, so let's go back to the higher order framework. Then what we try to do is we try to recreate the whole thing with an impact-based system then. So what you need to do when we want to reconstruct this higher order framework with our intention or with our purpose in mind is, when you are developing this basic component or basic study itself, or when you want to develop a master or a PhD using the problem you have identified, you have to involve all the stakeholders involved there. So you should not be waiting at end to see that, okay, after this one go to the level 4, I will see whether this can be converted into startup or unicorn. And this is a risky factor. So you have to involve the stakeholders right from the starting, and you should also be very carefully and consciously seeing what type of knowledge society this will create for the people who are involved over there, right? To do that one, I will explain with how to do this level composition there. So when you want to do this level 1 to 2, there is between basic principle concept stage here. You need to have these 3 components in place here. So whether your research problem, of course, any research problem will have some concept there. That means you have an idea, you convert the idea into become a concept. Then it will be having some sort of technical merit, right? You want to have some technical solution for the problem, right? But the important component, what we miss out, is the business value there, right? So you need to also look into the business value, right? Whether my solution for the research problem will be able to generate this business value for the solution or not. Business value for the for my research or not. If there is no business value, there's no point for you to go into this concept and the technical component there. When my PhD students come in with a proposal, I ask them this component there, right? Because this one everybody do, concept and technical everybody do, right? Without this one is engineering is not there, right? But does it has a business value in the market or not? If there is no business value, then there is no point for you to do the research at the first phase itself, right? So this is some of the inputs you guys are given when I ask you to fill in the purpose statement, right? That's why I call this a purpose statement or an intent statement. You can call this an intent statement. If you look from here, everything is I'm not complaining, but if you look at here, everybody is saying that we want to do something. Technical merit is there, concept merit is there, but where is the business value, right? If you look from here, is to develop a cost effective, right? Cost effective here become a business value component over there, right? So lightweight, for example, is an indirect business composition over there, right? But the merit is whether at the end of your research, this can be visualized or not, whether this one can be visualized or not. So if we say cost effective, then we should be doing some sort of cost analysis at the start of your research design, even before you are designing over there. I'm not sure that whether you will be doing this one or not. But if you're doing, it's well and good. If it's not, then you have to do that type of cost analysis even before you do over there. To summarize this one, right? When you have this one concept idea, technical idea, and business value, you'll be having a number of ideas pouring in, right? So we use this once again the code framework, which I have earlier shown, where we try to put this one in a mapping part here, and to say that who is the user, right? And for example, you are the provider, and you are you find the end user there. Then you try to see that my end user is looking for a cost functional or impact functional. Cost means it can be low cost, high impact, low impact. Then you try to map it as many as possible. The hurdles. If I want to create a high impact solution for the problem here, what are the challenges I'm going to face here? Put the hurdles, all the hurdles here. Then try to match it back with what will be the solution to solve this hurdle from here. If you look at the bottom quadrant here, it's talking about the hurdle. In other ways, you can call this as a pain points here. Then this is the pain relieving component. This one is basically the gain component. What things I can add on that can make the existing system to create an impact at the same time to create high value. That means gain creator from here. So you have to jot in as many as hurdles as possible, right? As many as challenges while you are trying to come up with a low cost product or a high impact product, or of course we don't want to create a low impact product, definitely no, right? So you have a low cost and a high impact. If I want to create this one, what are the hurdles, and is it a possible ways for me to resolve it or not, right? So if I solve this problem, then I will be getting a better product or a better process or together as a service from that. So this mapping will be very, very helpful for you to do, because you have to be mindful that you are not here to solve every other problem for that, every other challenge of that particular problem. You need to take a critical challenge among all the challenges here and try to come up with a solution. That means most critical challenge, what it is. Then can I produce a resolving for that challenge or not, right? To do that one, what I need to do, right? Doesn't mean that the other challenges are not important. It means like you are trying to apply the boundary to say that among this one, I feel that this is the biggest challenge need to be solved, and I come with a resolving component from that, right? Then you can use this fit component. Fit stands for how do you fit the challenge with the resolving component you want to get. When you want to fit these two components, you have to use the business value. Whether whatever the solution I'm providing, is it economical for it or not, right? So you have to be mindful that any challenge will have a solution, right? Whether the solution can be cost effective, whether the solution can be adaptable is what the key component there, right? After you do this one, you have to use this mapping part. We call as a but component here. We will have to look at whether the challenge and the solution you are providing here, the biggest challenge or the most critical challenge you have picked up, and the solution for it, whether it has a business value, whether it can be served for a particular domain, particular people, particular segment, and whether it can be technologically adaptable. Technology adaptable is very highly important, is because these days without mobile phone or without Internet of Things, it's very impossible for us to have think of any other application there. In the future, everything is going to be controlled through a semi-automated or fully automated system. So there definitely you need to have a point of view on this technology adoption there. So for one example is you're developing a system that can be adaptable only by 3G. Right, as we know that Malaysia, for example, 3G, they are going to close it by December 31st. From 1st of January, everything will be 4G. That means you develop a solution, but can be adaptable only for 3G. That means the solution might not be feasible there. So that's what it can be, the technological adoption there. User specific. For example, if you're catering only for 1% of the total process industry, right, then it's not going to be helpful for you to build the system there. It's not going to be economical for you. Right, so that's what we call user specific, whether your market size is small, big, or very big. Right, and of course business value is like how much money you invest on the manpower, how much money you invest on the equipments, tools, and the techniques. Right, that should be calculated in order for you to see that the solution is a viable solution there or not. So for after you do that one, you can come up with a relook into your catalyze statement, or we call as a purpose statement, or you can call as an intent statement. Your intent for the unit or your center or your research group is to develop what a low cost, high impact. For example, handheld cutter for agriculture community. This is for specific people there, right? And this is to reduce the ergonomic impact, right? How to create an less impact for the health point of view for the farmers, right? That's what here from here. Then you can look at you can create your own core purpose. What is the key knowledge gap? What is the current state of the system? Who will be the target groups? What will be the hurdles? And where you stand, current state, and where you wanted to have what we call as a desired state from there. Okay, the second stage, of course, after you develop the solution here, the next stage is for you to go for the validation and the demo, right? So when you want to validate a demo, you need to have a proper execution period there, right? Whether you can devise this whole solution within a particular time period or not. For example, you come up with a solution, and when you want to translate this solution into an executable project, it will take about 5 years of time period. Nobody wants to buy that product from you, right? You need to be very specific in putting up the things there. Some of the project solution needs to be very critical, right? Some of the project can be in longer duration. So you have to identify how to organize your project, your idea, concept, right? Your idea to become concept. Then now the concept needs to become a project. So you have to organize and find a way to deploy your thought process in a specific period of time, right? In a simple way, this is nothing but a Gantt chart. Yeah? So like in a Gantt chart, you will be having this scope of your project, your budget, your milestone, and then your period of time period, right? But the important part is like you need to tone down to this triangular component here, right? Your cost, scope, and the time will become the component here, right? For example, because of the COVID, if your project is not able to move on, that means it's still making you a recurring cost. That means the cost is becoming higher, right? But the scope still remain the same. The time period is becoming smaller. So that means this will not become an equilateral triangle anymore, right? So you have to tone down either the scope, or you have to cut down the people, so that, the centroid is always at the center point of the component here, right? So this is the second stage you have to design even before the execution of your project. First stage is idea, convert into a concept, make it as a framework. Now the next step is like, how do I am going to convert this framework into a project? Within the project, I need to have a cost, scope, and the time. What is the risk factor of the cost? What is the risk factor of the scope? What is the risk factor of the time period there? For example, if suddenly a natural calamity occur, so you cannot move the project for 6 months of time period, what will be the risk mitigation plan, right? So those type of things is what you have to decide on the level 3 and level 4 component there. Okay, so once you know that this one is done, the next step is like bring this one, an upsize model or a proof of concept to the validation, real environment validation, then bring back to the venture capitalists or a joint venture or startup or unicorn to upsize it or to make it to become a larger production or mass production component here. So one thing you have to remember while executing the project is like a product in a project is how many percentage of this project component can be reused, right? How many percentage of this product can be having a secondary life? How many part of this percentage of this whole project need to retire? Meaning that, for example, if you're using a battery in your project, right, what will be the end cycle of this battery, whether this battery is going to be used to the secondary market or not, right? If you are using, for example, a panel in your system there, what type of maintenance you're going to use for the panel, whether this panel can when the panel can give you the return on investment on the money you invest on the panel alone, right? Like for example, as you know that a panel investment, it will take about 3 to 5 years of time for you to return your investment for the panel alone, right? So that means there is a maintenance cost on the panel over there. So these things is what you need to see when you're doing the cost analysis component there. So then the next one is also, you need to also look at, okay, now I developed the solution, right? Next step is like, I want to bring the solution to the market. Is there any active partners there who can bring the product to the market, or I have to go by myself or not? For example, when we do a project on electric vehicle, we coming with a pulse charging, a new type of pulse charging method. So our job is not to go to develop the whole EV system. What we try to do is we try to develop the power electronic component. Then we bring on board an EV player there, and to say that, okay, our job is basically to come with an advanced power electronic control over there, which you can use in your EV system. Thereby it can become like a rapid charging component there. So in that way, it will be less investment for me. At the same, it will become like a win-win percentage for both of us there. Okay, is what we call as a partner. You need to identify who are the partners locally that can bring to the market your product there. Then what are the type of activities you need to provide? What will be the implementation phase, right? How long it will take to implementation phase? And as I mentioned like that, value towards sustainability is environmental, society, and governance, right? You call it ESG. How this project component or project itself is going to contribute for the ESG component, environmental, society, and governance component over there. Okay, so you put everything in place here, right? What I'm trying to invite you guys is not to do this one by stage. You have to do the whole thing even before you start to think about executing a simple solution for a project there, right? So if you have that process in mind, that where I know that very clearly in 2 years or 3 years of time, this is going to mature this way, and this is going to end up with these people in the society, and then your research, then you are constructing your research with an intention. The intention is very clearly towards a society called, for example, agriculture society, or for process industry, or for tourism industry, or for hospitality industry, whatever may be the industry over that. So you can use this template to start with, to see that where you are. If you are somewhere here, it's time for you to relook into, go up to the level 7 to see the potential of your project. If there is a potential, then you need to start to loop it back to see that whether L7 to L4 can be reworked for you or not. If not, you have to, it's better that you scrap the work, then start from something which the industry needed, to start with the fundamentals and try to build from the system over there. Because this is the last stage of your project there, where we try to see that whether there is a minimum viable product that can be saleable to the market or not. Okay, I show you 2 examples for how we do in a project with research with intent there. This is a project which me with my supervisor from University Putra, Malaysia, we did together, but I was into the project only at level 3 time, because before that he started this project already. Before that he don't use this type of L1 to L7. He tried do the conventional way of doing the things there, right? When I joined them, then we use this type of code framework there. We use several code tools there. What you're seeing as a code tools, a number of tools there. We use these tools to come up with a solution for the biggest challenge in Malaysia's plantation industry, which is cutting the palm tree from the palm fruit from the palm tree. Okay, palm tree is a very hardest tree, and it's very difficult to cut with a normal sickle there, right? So you need to have some sort of manpower, I mean physically built, who can cut the system over there, right? So in earlier times, what we try to do is we try to use our machine design knowledge to build a system that can be driven with a conventional fuel-based system. That means we use an engine. Engine is pulling the shaft, and the shaft is able to connect to the sickle, and the sickle will cut the fruit from there. Then later we convert this one. Later he converted this one into a motorized cutter, where we use some sort of a gear mechanism at the top part here. The gear will increase or decrease the speed at the sickle component through a rope mechanism here. Thereby it can cut the palm tree from there. Right. So then what happens is, then when I joined for L3, we know this problem is coming from the agriculture sector. We develop the system here, but when we want to move to the next level, it's very difficult for us to do, because we understand from their when we survey, when we interview them, they give some input, then we go back, we build the system, but this is not suiting once again for them. Is because engine itself is very heavy, and handling this engine with the fuel is just like carrying a small bike in your hand, right? Once again, it's ergonomically is not suitable over there. Okay, so what we try to do is we try to go back to using this core type of component here, and we try to see that we want to solve not the problem of cutting, but we want to solve the problem of ergonomic discomfort, right? So we change our problem statement from coming with the solution of cutting the tree, cutting the fruit, rather than now becomes like how to reduce the how to make this ergonomically very comfortable component there, right? So then we come up with this framework, then we use this one, come up with a different type of funding mechanism. We use, for every funding mechanism, we use this framework. Then we develop, we use a linear actuator here, as you can see here. Then we use then we move the engine. We thoroughly remove the engine and come up with a motorized cutter here, because sometimes when you use the engine, this generate the carbon, and that is not healthy for the people who is cutting the in the plantation industry also there, right? So we replace the whole thing by the motorized cutter. We come up with a several model, and then one model where we try to come up with a lightweight. At the same time, the motor is at the what we call it at the very static position. That means it can be this rope, this extension can be is flexible, and it can reach up to 12 to 13 meters easily, right? Then we develop this one about 10 units. Then we give to the farmers a different part and ask them to give us the feedback, right? Then they gave some feedback. Then we come up with some sort of a final model, and now this final model is certified and it's been commercialized by the farmers. This is the very first product where they are using the engine component. Just for illustration, we use this picture over here. So this is how this intent research with intent can be built up, so that it can end up with this component here. And of course, if you ask me, this is a final product. No. Now what we try to do is we try to replace this magnet, because all the machines is using a magnet base. Now we are trying to come up with a magnetless machine using a reluctance machine. Those are on machine design, they will be knowing. Reluctance machine is an alternative, so that we can reduce the magnet weight. Once the magnet weight is reduced, it will further reduce the ergonomic discomfort from the system over there. Right. So this is a transition of our L1 to L7. Now you can see L1, L2, L3, L4, L5, L6, then L7. Now this becomes an L1 here. But since we know this process already now, right, it's very easy for us to go through this L1 to L3 easily. Right. Now its important component is much on the L4 and L5. We don't need to worry about L6 and L7 because we have a prior experience of going through this certification and commercialized component over there. The other project which we are currently in level 3 is on developing a futuristic aircon for Daikin, Malaysia. So we are coming up with an aircon that can solve the problem of that can indicate that the space you are working or you are residing or taking food, how far it is health effective, how far it is health consciously is good, right? As you know that COVID is a transmittable disease there, right? And it by measuring the impact of the different type of sensing component within the room, right? Then whether we can measure from the health point of view, create some sort of awareness or not. This is what we are trying to do with Daikin on board. At the same time, we also want to create an impact for generating an energy efficient aircon, right? We started with energy efficient aircon, but suddenly COVID comes in picture. Now we propose to them as whether we want to add on with another type of sensors that can give some sort of indication that not alone COVID, it's some sort of indication that it is it's not healthy, air circulation within a particular premises or not. Right? We use COVID because easy for us to get the grant. That's why we use the COVID. But technically, it can be anything, any type of, like any type of disease that is related with the carbon dioxide level, the nitrous level within the premises there, right? Basically, it's nothing but putting sensor, collecting the data, pushing to the cloud. Then the cloud comes with an algorithm, and the algorithm can revert back to either display or it can be controlled. That's the whole idea of this project there, right? This project is now funded by Daikin. We are in level 3, level 4 there. So we use our final year students to come up with a proof of concept first. Then we pitch this one to the several parties there. Then we partner with the aircon industry Daikin, and also we partner with a scaffolding. This is a scaffolding unit there. Which pitch to them to see that whether they can be on board to retrofit certain part of the building so that it can become like a ventilation can be more effective, right? Though there is an aircon there, we still want to see that there can be some sort of ventilation component over there. Right. Okay, just to give a summarize of what you can take away from this session is like try to build up where you are with your whatever the research you have, to see from whether you are still in basic research to applied research, whether you can able to whether your system can create a value or knowledge society or not, right? If you are not going towards this value creation knowledge society, then it's time for you to rethink to say that okay, whatever you do as a research is not an innovation. It is not going to drive towards innovation. If it is not going to drive towards innovation, that means it is not going to create a value. If it is not going to create a value, it is not going to create any purpose. That means there is no intent in your research at all. Right? I'm not trying to scare you, but try to retrospect yourself to see that what you're trying to do, and from there you try to see what it can be. Do slowly, not necessarily you have to become like an innovator, tomorrow, right? You still have 3 years. Maybe you can plan for 5 years, 7 years, 10 years. Slowly you can plan for it. Then try to put in whatever the projects you are trying to do. See that. And within your scope of your project, which one can move to this level or which one has a market demand. Then talk with your market people there to see that what problems or what challenges they are facing or they're going to face in the next 2 or 3 years of time period, right? Then bring back to as a basic problem here. Then try to brainstorm within your research team to come up with an idea. Because some of our ideas, what you see as the patterns which we mentioned earlier is all coming from a very basic physics principles there, right? A very basic mathematics there, right? So if you go back to your fundamentals, you can come up with an idea and try to, the important part is how do you convert this idea to become like a concept, right? So if you're not able to translate this idea into a concept, then that's a weaker link of us, because ideas, anybody can do, anybody can think, anybody can come up with a multiple ideas there. But how do you make this idea to become like a concept, right? It's a key component in your design here. Then you can come up with the putting up, define your own indicators there, then I put in all the hurdles there, then prioritize. Probably you can like a red, yellow, blue or something like that. You put the prioritize, you put the dots here, right? Maybe you can use a sticky notes. In our research lab, what we do is we put this one in the whiteboard and ask our students to come up with as many hurdles as possible individually. Then I define the indicator. Then the students will define, like for example, if it's most significant, they put a green here, green here, green here, green here. From there, you know that which one is having more green. That means that is the most significant problem you have to choose it, right? Then you can see the fit component, which I mentioned earlier, right? Using that, using this type of, using this one, right? Using this one to come up with the, put up all the hurdles there, right? Put the resolver here. Then pick up the best fit component. For doing the fit, you use this term, business value, user specific and technologically adaptable there. So that actually helps you to helps you to understand what you need to throw out, what you need to eliminate, what you need to reduce, and what to rise, and what to create, what type of things. Then you can once again prioritize based on the color code. I like color code is because color actually gives me more indication there. That's why I use the color code for us to do here, right? Then come up with this worksheet here. Then put the worksheet into this one. You define this one. The next step is define this one. Then define this one and define this one, right? Do from L1 to L7 even before you think about solving a problem. The biggest mistakes we do, including myself, is we see a problem, then we straight away jump into to come up with a solution over there, right? That's the biggest mistake. You need to see to the end. You need to have a cognitive walkthrough, right? Starting from L1 until L7 there, right? Once you have a cognitive walkthrough, then you can discuss with your team, with maybe or discuss with your industry partner, and to see that this is what I have an idea, this is the concept I have, this is what I want to move from this end to this end, and these are the grants I'm trying to target, and this will be ending up with this type of commercialized component. Get feedback, then you try to pitch that one to the component there. Okay, so these are some of the trainings we do based on this code framework there. So including some of the universities from India, we train their students from year 1 to year 4 in India, Bangladesh, and also in Philippines. Sir, if you guys are interested, please let me know. We can arrange for either as a micro credentials or as a credit transfer. If you have a free credit, we can do some sort of free credit for you also. Thank you very much. I think I am on time. Maybe I leave for 3-4 minutes for questions, and if you have some time, then we can play the Kahoot game. Yeah, thank you very much. Yeah.
Thank you, sir. If you have any queries, faculties, you can ask, sir.
So this is the code game. So 3647811. This is the code, Kahoot code. If you want to, if you would like to play a game, maybe seven questions I have. Probably we can play some game there while I'm answering the questions from the people there. Yeah. Yeah, you can also feedback if you have something, which I can also take home, right? Not necessarily whatever I say is the correct, right? So probably you may be having your own opinion, or if you have any questions, please feel free to ask. If you have anything to discuss, feel free to discuss, please. Yeah.
Hello.
Yeah.
Good evening, please. Sir. This is Dr. Hema.
Hi, Hema. Yeah.
Yes, sir. So that was a wonderful presentation on research. So I have a question. You have mentioned about the cost analysis. You have to focus. If you are mentioning about cost effective, have to do the cost analysis. So how
sorry, I cannot hear you properly. Sorry, I cannot hear you properly. The question is like how to do cost analysis. Is it? Am I correct? How to do cost analysis?
Hello,
Is it?
am I audible, sir? Yes, sir. Yes, sir.
Okay, so okay, cost analysis is like for example, if you are developing a bigger project, for example, a solar, very big solar project for the whole of AVIT, for example, right? So then it's okay. The costing is all about, you have to start to think about from the main material, the tools, the techniques, like including yourself as a people there. We call as a man hour component there. Like, for example, if you are spending 1 hour per week, then that is considered as some points there. Then you have to analyze for the whole costing over that, because sometimes when we do the project, even when we want to seek the grant, we don't take our man hours as a costing factor there, but it is also should be considered as a costing factor there. There are a number of tools available online. If you go projectmanager.com, if not mistaken, they have the tools there where you can enter your informations there. So it can calculate how much is the cost effectiveness of your project there. I think projectmanager.com, if not mistaken. So yes, you have to do cost analysis. Like, without cost analysis, I think there is nothing free in this world, right? So you have to take care of this cost analysis component there. Yeah.
Thank you,
I hope
sir.
we answer your question. Yeah.
Thank you, sir. Yes, sir.
So if you guys want to join for the Kahoot, I think I see only 3 of them. So you just go to Kahoot, either download Kahoot or you can so I hope that probably we skip this one, Dr. Sangeeta.
Yeah, we'll skip this.
Okay, thank you. Yeah. Because I think it's 5:30. I mean, it's 3 o'clock already, right? So yeah, as promised.
Thank you, Dr. Aravind. Really, it was nice hearing to you.
Yeah, sure. Thanks. Yeah.
Thank you, sir, for articulating research intent levels with key points like concept, technical, business, cost, scope, and time, and maintain, evolve, and retire. We really came to know what is the key value of all these points from you from today's session. Now I request Dr. L.K. Hema, Professor and Head of ECE and Biomedical Department, to deliver vote of thanks.
Thank you, Mrs. Subhapriya. Very good evening to one and all joined here for this international webinar. It is my privilege and deemed pleasure to propose vote of thanks during this ACCE event, international webinar on constructing research with intent. On behalf of our management, principal, AVIT Center for Continuing Education, and on my own behalf, I wholeheartedly extend my thanks to today's chief guest, Dr. Chockalingam Aravind Vaithilingam, who is the Program Director, Faculty of Innovation and Technology, Taylor's University, Malaysia, for his informative and useful session on with fit the various modules and higher order levels framework with various levels, level 1 to level 7. And so, next, I extend my heartfelt thanks to our beloved principal, who is the brain behind ACCE, and all.
Hema, ma'am. Ma'am, your voice is not audible, ma'am.
Ms. Subhapriya, you can complete the formalities.
Yes, sir. Now I'd like to thank our principal sir for organizing such a webinar, and I would like to thank our coordinator ma'am, Dr. S.P. Sangeeta ma'am, for inviting such a valuable speaker. I also thank the coordinators of ACCE committee and also the faculty friends of AVIT. I thank you all. Now we have come to the end of the session. I request you all to stand up for national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, Dr. Aravind.
Okay, thank you. Thank you very much. See you then.
Yeah.
Yeah, sure.
Thank you, sir.
Bye-bye. Okay, bye-bye.